Namaste children, how are you? You are eagerly waiting for science class, right? Yes. Today we are going to learn about what? What are you seeing? Yes, diamond, the allotrope of carbon. Then let us study about diamond. So I welcome you to the Samveda e-learning program. So in this session you are going to learn about very important chapter, that is carbon and its compounds. This chapter is subdivided into 5 subunits. So you have total 5 sessions. The learning points of the first session are importance of carbon, then covalent bonding in carbon, then properties of the carbon and its compounds, then electron dot structure. Now let us begin with the session number 1. Here you are seeing jute fiber, this is switchboard, charger, screwdriver and cutting plier. Let us have an activity. What is that? That is the activity 4.1. Make a list of 10 things that you have used or consumed since the morning. Are you ready? So you should prepare for this activity. I hope you are ready with textbook, notebook, pen. Now what you have to do, if there are many items which are made up of more than one material, then put them into both relevant columns. Observe the table. What are the materials I have used? The metallic substances you are seeing here, screwdriver. Yes, I kept in others column, right? Why? Screwdriver has a metallic body, screwdriver has a metallic part as well as the handle which is made up of plastic. So I kept in 2 columns. Similarly, stove at your home, metallic body with plastic knobs. So I kept in 2 different groups. Now the lighter contains metallic body with the handle made up of plastic. Then iron nail, hammer has wooden handle or plastic handle. So once again I wrote here. Similarly, cooker, already you know cooker has thermosetting plastic bakelite. The handle is bakelite, hence I wrote here also. Then mirror, lenses, you can write lens here if it is having a handle which is made up of plastic. Mirror if it is having a plastic body. Okay. So beaker, pot, these are the materials either made up of glass or clay. Then other than these two, we have so many things: food, cloth, pen, pencil, etc. You can tabulate here. Thus you made 3 columns. What is the others contain? Yes, these are made up of carbon compounds. Carbon compounds are there in our nature. Many things are based on the carbon only. This is called as versatile king. Carbon is king of versatility. So here you are seeing how many protons, how many electrons. Yes, the carbon has 6 protons and 6 electrons. All living structures are carbon based, but this carbon is present in the nature in very small quantity, just only 0.02%. That is the carbon present in the earth crust, that is in the form of carbonates, hydrogen carbonates, then fossil fuels like coal and petroleum. And it also present in the atmosphere, as you know, 0.03%. Very meager amount of carbon is present in the earth, but it is very important. In the spite of the small amount of the carbon available in the nature, the importance of carbon seems to be immense. In what way? Yes, it is found in many things. What you are seeing here, what you are seeing is the lipoproteins found in cell membrane. This is the DNA, this one is protein, insulin. That means it is a part of our body. Our body structures, cells, tissues, organ systems, etc. are made by these carbon compounds only. So, the food, clothes, medicines, books or many things that you listed now are based on this versatile element carbon. Probably you understood now what is the importance of this carbon. Now here you are seeing some more things. What are they? So carbon in different form. This is the graphite. The next one is what? Carbon nitrogen compound. Then here you are seeing this is what? A protein. This is a buckyball, soccer ball, fullerene. The next one is cyanocobalamin. This is called as vitamin B12. That means once again carbon is present in different form, in different places in living system also. Now, what is the study of this carbon called? The study of carbon is called as organic chemistry. The branch of chemistry deals with the study of carbon and its compounds. Remember, excluding simple molecules like carbonates, oxides and carbides. Excluding this, all other carbon compounds studied under organic chemistry. Earlier it was believed that only living organisms able to produce carbon compounds. This theory is called as vital force theory that was given by Jöns Jacob Berzelius, who is known as father of vital force theory. There is a vital force in the living organisms synthesizes carbon compounds. Later on, a doctoral student of J.J. Berzelius, he disproved this one. Now, who is this? Just now I mentioned the name Friedrich Wöhler. In the year 1828, Friedrich Wöhler synthesized the organic molecule synthesized by the living organism, that is the excretory product urea, by heating ammonium cyanate. This disproved the vital theory proposed by J.J. Berzelius. What is this? This is the structure of carbon. What is the atomic number? Total 6 electrons means 6 protons, that is the atomic number 6. What is the electronic distribution? Already you are seeing here, that is K shell 2, L shell 4. Now, how many valence electrons are there in the carbon? Yes, simple. You know this one, 4 electrons are there. Now, carbon has 6 protons and 6 neutrons, altogether 12 particles are there in the nucleus, hence its mass number is 12. How the carbon attains stable configuration? All the elements have the tendency to attain the octet or duplet, that is the stable configuration. Carbon has 4 electrons in its valence shell, so it needs 4 or it has to lose 4 to attain stable configuration. When it attains 8, it attains the structure of neon. When it attains 2 in the valence shell, it will be the helium structure. Now, that is the crave for stability. If it gains, what happens? Let us see. The carbon could gain 4 electrons and become carbide 4 minus, see 4 minus ions, but it would be difficult for the nucleus to hold these 10 electrons, because carbon's nucleus is having only 6 protons, holding extra 4 electrons become difficult, hence stability is not achieved. Then white will go for that. So that is ruled out. What you are seeing here, how the carbide ion is formed, you are seeing in the animation. In the valence shell 8 electrons but 6 protons cannot hold them. Now one more option is, if it loses the electrons, what happens? See this animation. Yes, it lost 4 electrons, only 2 electrons are there now here, what you are seeing. But then what happens? It will become C4 plus cation, but it would require a large amount of energy to remove the electrons. That much of energy is not provided by any of the atom, hence this also not possible, right? Now you are seeing here, what is the net charge? 6 protons are there, only 2 electrons are there, then net charge will be plus 4, that's how C4 plus cation, right? Both methods are not possible, means it will solve the problem by sharing the electrons with other atoms of carbon or any other atoms. Not just carbon, but many other elements like hydrogen, chlorine, nitrogen, oxygen, fluorine, bromine, sulfur, etc. So it can share the electrons. By this it will teach us a wonderful lesson, live and let live with harmony, by sharing our things. Such a great, wonderful. So that is the novel character of the carbon. We have to learn from this non-living carbon, right? Now let us move on to next one. That is the share and stay together. That is the motto of carbon. The shared electron belong to outermost shells of both the atoms and leads to both atoms attaining the noble gas configuration. Let us understand what is the electron dot structure. Here you are seeing a compound methane CH4. You are seeing here carbon has 4 valence electrons which are represented in the form of green dots. Similarly, hydrogen has only 1 electron which is represented in the form of a black spot. Now both want to attain the stable configuration. For hydrogen, 1 more electron is required, so it shares with the carbons. So it attains helium configuration. Similarly, this carbon, it shares the electrons with 4 hydrogen atoms, indicating achievement of octet. Now see here, after the sharing what happens? Electrons are revolving around both the nuclei. That means they are available for both. Now what is covalent bond? This just now what you saw in the previous slide, that is the formation of covalent bond. The bond formed by the sharing of the electrons between 2 atoms, that is covalent bond. Here you are seeing hydrogen, 1 line between 2 hydrogen means a pair of electrons are shared. Here you are seeing the oxygen, 2 pairs of electrons are shared, so double bond. Nitrogen, 3 pairs of electrons are shared, a triple bond. Thus electrons were shared between 2 atoms, then covalent bond is formed. This is how the covalent bond forms. Now let us see the formation of a diatomic molecule, hydrogen. So both hydrogens need 1 electron, as they have 1 electron in the valence shell. K shell can accommodate maximum 2. Now they share, and you are seeing these electrons revolving around both the nuclei. That's how the stability is achieved and hydrogen molecule is formed. The atomic number of oxygen, what is that? 8. Then electronic configuration, K shell 2, L shell 6. How many valence electrons are there? Yes, 6. So you have to write dot structure for each oxygen. See, oxygen nucleus surrounding that one, they have what is? They have 6 electrons. So valence electrons are represented. This is called as Lewis dot structure. Hence, they share 2 electrons between them, then a double bond is formed, you are seeing here, right. Now, the formation of nitrogen molecule N2. First you have to write the electronic configuration, nitrogen atomic number is 7, hence K shell has 2 electrons and L shell has 5, right. So, valence shell has how many electrons? 5. Both the nitrogen atoms need 3, hence they share 3 pairs. That is what you are seeing here, right? Yes. Like this you have to write the electron dot structure, very, very important. So, it will help you to score marks. Now, let us write the EDS, electron dot structure of carbon dioxide. Try to write. Are you writing? Try. I will show how to write. First you have to write carbon in the middle, oxygen on either side, left and right of carbon. So represent carbon's electrons. Carbon has 4 electrons in the valence shell. So oxygen needs 2. So 2 electrons of carbon shared with 2 of oxygen, then oxygen gets 8. Another oxygen also does the same thing, so carbon's valency satisfied, meanwhile oxygen's too, thus carbon dioxide is formed. Now let us have the EDS of, that is sulfur S8 molecule. It's a wonderful molecule. See, nature is so beautiful, it creates so beautiful things only. Now sulfur's atomic number 16, the valence shell has 6 electrons. Then what is the structure? It is the structure of a crown. So these are also like the crown. So this queen, see how is that? Check how many atoms are there. So first line you are seeing 3 plus 2 5. So 6, 7 and lastly you are having 8th one. Thus S8 molecule exists. One more homework for you, you try yourself S6 molecule which has the shape of a chair. Try to write this. Alright, let us move on to next one. The properties of the covalent compounds. Generally, these are bad conductors of electricity. What you are seeing here, observe the ammeter. Any deflection? No. Even though it is connected to battery, there is no conduction because there is no ions are formed. Observe, what is there? You are seeing deflection in the ammeter. The ammeter shows the deflection means current flows. Even you are observing the movement of electrons also. So that means the molecules which produces ions, they are conductors of electricity. If not, they are the bad conductors. The covalent compounds does not produce any ions. That's why there is no conduction of electricity. That's what you saw in the previous slide. Hence you can conclude covalent compounds are bad conductors of electricity. Now what about the melting point? See this animation. So slowly when you apply the temperature, the molecules start, there is a vibration. As a result, the melting of solid takes place. When you increase the temperature, now they started to move randomly. This is the gaseous state. Generally, the molecules have the force of attraction. If it is very low, the intermolecular force of attraction between the hydrogen and hydrogen is shown here. That is very low. Then very less amount of heat is sufficient to break or separate these molecules. Hence they have low melting point and low boiling point. Some of the organic compounds are listed here and their melting point in Kelvin and boiling point in Kelvin are given. The first one is acetic acid CH3COOH. What is the melting point? 290. Then 391, that's the boiling point. Chloroform 209, very volatile compound, 334, that's the boiling point. Ethanol, whose melting point is 156 Kelvin while boiling point is 351, while that of water is, yes, 373 Kelvin. Similarly, methane 90 melting point, then boiling point will be 111. These are the organic molecules. Let us compare sodium chloride, whose melting point is 1074 Kelvin or 801 degrees Celsius. Much higher. What is the inference? Yes, organic molecules have lower melting point because between the molecules intermolecular force of attraction is weak, so small energy is sufficient to break, right? Now see this chart. Here you are seeing the methane which is having least. This is hydrocarbon having only hydrogen and carbon, while others are having hydrogen, carbon, oxygen and chlorine also. Other than hydrogen, carbon, some other atom also present, their boiling point, melting point also increases. What do you mean by allotropy? This is the phenomenon that an element exists in different physical form, but all the physical forms show similar chemical properties. Carbon do show these allotropes. The element carbon occurs in the different forms in the nature with widely varying physical properties. That is the melting point, boiling point, refractive index, etc. are said to be, yes, physical properties. But these are showing similar chemical properties. Example, diamond graphite fullerene. This is the structure of diamond. Remember children, diamond is the hardest material occur in the nature. Observe the structure carefully. Here one carbon is connected to how many? 1, then 2, 3, 4, right? That means each carbon is connected to 4 different carbon atoms. This forms a 3D, very rigid, very hard 3D structure. Hence, the diamond is the hardest material. Do you know this? You have this one in your pencil. That is the graphite. In the graphite, each atom is bonded to 3 other carbon atoms in the same plane, gives rise to a hexagonal array. One of these bonds are deemed to be a double bond, and thus valency of the carbon is satisfied. This is found in your pencil. That means it is very smooth and slippery. Here you are seeing hexagonal arrays which are arranged in the form of layers. The bond length between 2 layers is too much, nearly about 340 picometers. That's why they slide one above other, hence better lubricants, very soft, right? And this graphite is a very good conductor also, because the 4th electron, which is loosely bound, easily broken when the potential difference is applied. Hence, this is a very good conductor of electricity. Hence, it is used as electrode. Now, the diamonds. We can synthesize the diamond in the laboratory. Is a wonder? Yes, it's a great wonder. You cannot differentiate the artificial diamonds produced by this process because they are exactly similar to naturally occurring diamonds. The diamonds can be synthesized when you apply high pressure and temperature to the pure carbon under that high temperature and pressure, they are converted into diamonds. These are too small, but they resemble the naturally occurring diamond in all other aspects, hence they are indistinguishable. A soccer ball, buckyball, right? This soccer ball is called as fullerene, carbon 60. Here carbon atoms are arranged in the form of a dome. This is similar to that of the geodesic domes designed by US architect Buckminster Fuller. Hence, they are so called as fullerenes. Here is the Richard Buckminster Fuller. Here you are seeing his designs also, so beautiful. Similar structures are seen in the nature, that is carbon 60, hence those were named as fullerenes. Now this is the quiz time. Let us test what we have learned till now. Are you ready? Yes. Here is the first question. The boiling point of compounds formed by the sharing of the electrons is, here are your options. The first one is high. They have low boiling point. Maybe more or less the bond has no relation with boiling point. What is your answer? Let us see the answer. That is, they have low melting point and boiling point. The question number 2. Atomic number of an element X is 7. What is the maximum number of electrons shared by this atom? 7, 5, 3 and 1. What is your answer? Yes, let us check. The answer is 3. Next question. Soccer ball shaped molecule is, what is that? Diamond, graphite, S8, fullerene. What is your answer? Yes, you are right. Fullerene. Now we came to end of this session. Let us conclude with the homework. Please note down the questions. The first question is, define the term organic chemistry. Second question, how will you explain the stability of carbon atom? The next one, carbon cannot attain stable helium gas structure. Why? Covalent compounds are bad conductors of electricity. You have to substantiate this statement. The next question. A student argues that even though graphite and diamond exhibit different physical properties, they show identical chemical properties. Will you support his statement? Explain. Last question. Draw the electron dot structures of NH3, ammonia, H2O, water, C2H6, that is the ethane. Dear children, till now you understood many important concepts related to carbon chemistry. What is the carbon's valency? What are the type of bond formed? How that bond is formed? What are the allotropes, etc. Probably you enjoyed this learning. And I hope you will translate this learning into marks in the forthcoming exams, right? Then let us meet once again in the next session. So till then, bye bye, namaste.